Hi, Seth Clark, head of product and co-founder here at Modzy, and excited to talk to you today about how to use production data as part of your model improvement, labeling, and retraining cycle. Now, before we get to the details, I wanted to congratulate you on the launch of your new app. You and your team have successfully launched a brand new social media app that lets all of your users share images and then paste them on a map where they can share them with their friends or family or just look at them together over time. And it's a really fun piece of software, and you're getting rave reviews. Now, the architecture of your app is relatively simple. Your users upload pictures from a smartphone or a computer up to your vacation SlideShare app. And then those images get saved in a data lake. And then when it's time to show them off, basically pull those out of the data lake and render them right on top of your app. Now that works really, really well anytime the images themselves actually include the location information about where the picture was taken. But every once in a while, maybe they're old photos, maybe you've got an out-of-date cell phone, that information isn't included. So because you're a machine learning engineer, you had the brilliant idea to include a machine learning service that will try to predict where in the world a picture was taken. So a relatively simple architecture add-on. What you've done here is added in an extra loop where those images that are sent to your app are deployed to a model service that generates a prediction, and then that prediction is returned back into your app. Now that works great about 80% of the time, but every once in a while, there's a mistake. And the prediction that your machine learning model comes up with is just wrong. Now, what do you do in that situation? Well, typically the answer is you need to improve your model over time. You need to retrain that model. You need to identify what aspects about the underlying data or the model itself potentially are lacking and resulting in a scenario where it's making mistakes. More often than not, it could be a new place in the world, a corner of the world, a new monument that your model has never seen before. So what we'd want to do is really get all of this information that your users are giving you for free, all of this awesome imagery data, and use it to retrain a model. But that's a relatively cumbersome process. Data labeling can take an incredibly long time. So how can we speed this up? Well, the great news is that your production data, along with the predictions generated by your model, are actually predicted labels. So you don't have to start from scratch. And with some simple architecture decisions, you can actually set up a training loop that allows you to take advantage of the fact that your model is probably pretty good at most of these predictions. And you can use those predictions to actually preemptively label the images that you'll use to train that model again in the future. And when there's mistakes, you can use tools like explainability to help inform both data scientists as well as your data labelers understand how and sort of what aspects of your model are potentially weakest. All of that information can then be used to label the mistaken predictions, and that final set of data with the correct labels from your model, the corrected labels from your labelers, and the raw data that's actually always saved and stored in your data lake becomes a new training data set that your data scientists can use to continuously iterate on improving your model. Now that's great. For today's example, we're actually going to walk you through some code where we'll do this with a couple of specific pieces of software. We'll be using Modzy for the model serving and the explainability component. We'll be using Dropbox as our makeshift data lake. And then we're going to be using Label Studio as the labeling tool that pulls in all of this information, both from the data lake as well as from the model serving engine. Now, let's take a look at the code that we're actually using to create this process. The first script that we'll walk through here is just simulating the experience that your users would have in submitting their images up to your service. So what we're going to be doing is taking each of the images in a local folder called images test. This would be simulating the experience of your users taking a picture with their phone and then pressing upload. And we're going to be sending all of these images to our inference engine, to an image-based geolocation model that will actually try to predict where in the world that picture was taken. And then once the image has been submitted for that prediction, it will also then be uploaded to our data lake. And in that case, it'll be available in Dropbox. We're naming the image once it gets saved to our data lake after the unique identifier of the inference job. which allows us to essentially connect those two pieces of data together downstream when we're doing our labeling. So it means that we'll have an image as well as a prediction tied together with the same key. And that's a really nice way to do it, because it means you don't have to move your data from your data lake again. You'll always have a convenient way of connecting those two together. You can think of it as kind of using a common tag. So we'll go ahead and submit a few images here to our image-based geolocation model. We'll see these start to process through. And then all those images will also show up within Dropbox in just a second. So I created a project within our inference serving tool called the Vacation Slideshow app. And we can use this to keep track and identify all of the predictions that were made as part of our application. So I'll head over here to job history, and we can see an example of one of these predictions. So here we'll see the model that was used. We submit it to this geolocation model version 1.0.1. And we can see here the predictions that were generated. In this case, this picture was confirmed to be from Cairo. Now we're going to have a chance to take a look at that with our human eyes and see if that was correct. As a data scientist, you might want to start exploring information about how your model is making some of these predictions. So we're going to jump over to explainability. This could be from whatever explainability tool you use. And again, you may just want to use a common key, come up with a common structure to link all of this information together. But we can take a look at our predictions and at the explainability masks that help us understand sort of what aspects of the image our model is using to make these predictions. So here we see an image of correctly identified of Amsterdam. And so we're just going to make a little mark here to indicate that this was a correct prediction. This will be used later on downstream during the labeling process. I'll talk about that more in a little bit. We'll take a look at a couple of these other predictions. This was indeed Cairo, so this was a correct prediction. And then I'm going to look at one other image here. This was an image that was predicted to be Chicago, but I actually happen to know this is an image of Dallas. So I'm going to mark this as incorrect. Now, typically data scientists are not the core data labeling team, but they're an important part of the loop, because data scientists can help connect the gap between understanding perhaps which classes were unbalanced, which aspects, which features of an image are corresponding with certain types of classes. Having a good understanding about how the model's original design and architecture may be influencing its performance. So capturing this information, this human in the loop feedback, is really helpful, because we can then feed this information to our data labelers to help them understand, for instance, what percentage of the predictions seem to be wrong and mistaken, so that as they're going through the labeling process, we can apply kind of smart sampling techniques. So we've got all this information. The last thing we're going to do is double check to make sure that all of these images were uploaded to our data lake. And we can see that they were, which is great. And we can see that they were named correctly after the identifier that we used to actually run the inference. So the next thing that we're going to do is now take all of this information, and we're going to send it over to our data labeling tool. So in this case, that'll be Label Studio. So we're going to be simply looping through all the images in Dropbox, our data lake. And then we're going to create a dictionary with all of the inference information that we're pulling, in this case, from Modzy. So we'll have an image, we'll have the prediction information, and then we simply have to format that information into a data object that Label Studio is expecting. And then finally, we can use Label Studio's API, and I'll be posting this to my local instance, post it there, and then we'll actually be able to work with all of that data right from our labeling tool. So we'll go ahead and run Python 3 import annotations. And now we can head back here to our Label Studio interface, and we should see, perfect, all of these annotations showing up. So this is great, because now through either a manual submission, a monthly process, or as part of a CI/CD pipeline, you can now pull together the data from your production data store with your prediction information, and use this to essentially pre-annotate, pre-append labels to all of your predictions, to all of your public data. So we have this image here that was identified as being Chicago. We can actually see here that the reference from Modzy was that this was actually not Chicago. So this can be used as a filter to help identify which images are likely in need of relabeling. We can go through this process here. And I happen to know that this is actually Dallas. So we'll scroll down here, and what a labeler can do then is correct this input. And what we'll do is go ahead and submit this, this prediction. We can go through this process. All of these were correct. This is indeed Athens. The prediction here is correct that this is also in London. Again, we can see all of these annotations have already been added because our model was correct. And then once this is all done, we can go ahead and actually go back to our interface here and export all of this as a JSON object. So go ahead and export that. What we can see here is that we now have a structured set of data that our data science team can use to start retraining this model. And one piece of information I'll just share right here at the end is that, again, what we're referencing here is the original location of the data in your data lake. We didn't have to move the image to 3 different tools. We're able to reference it in its, sort of home in all these scenarios so that you don't have to move data around regularly. And that can be a huge time saver, real cost savings as well, because network traffic can be kind of expensive. So that's the general concept. It's really about making a simple way for you to use the predictions you've already generated in your labeling process. If you're interested in playing around with this, we've open sourced the project here. You can play around with this sample. You just have to create an account in all 3 of these tools and then follow a couple setup instructions. The sample data is actually included right here within the repo. And if there are other ideas that you have, we're absolutely open for pull requests. So thank you so much for the time. I hope this is helpful, useful information. And I'm really eager to hear what kind of feedback and thoughts you all have and other tools and techniques that you found to be useful in making sure that you've got high quality training data based on your predictions in production. Thanks a lot.